Okay, we're getting up here with the higher lessons. I believe, again, this is either introduced in lesson 4 or in lesson 5. Create another expression that also represents the area and is based on the closest perfect square. So this equation, class, represents our area. The question is, can we convert this to a perfect square? And the answer is yes, but it takes a little bit of different logic on this to make this work. In your lessons, here's what we learned is, we're going to only look at these two terms right here. We're going to make a perfect square out of those two. The plus 4, we're going to kick it down the road. We're going to deal with that later. Because we already know there's a a C value here. We want to know, do we have to add or subtract something else to make a perfect square? So we're going to just do a perfect square of x squared plus 8x. So here's what we're going to do. Let's rewrite this equation as x squared plus 8x plus some number, and then we're going to have plus 4 at the end. And then class, if we add some number to this equation, we're changing the equation. So whatever we add inside the parentheses, we have to subtract it on the other side. And I don't like this, class, sorry. I'm getting painfully close to the actual diagram. I'm going to move that, so give me a moment here. I think I can move that over. There we go. That's better. All right, so let's go ahead. All we focus on right now is making a perfect square out of this trinomial. So we've got x squared. That's going to go inside the upper left. You see, class, is very consistent logic here. We've got 8x. We got to divide that up into half. So we got 4x here and 4x here. So far, class, I already know what my perfect square is going to be. It's going to be x times x is x squared. X times 4 is 4x. And x times 4 is 4x. Clearly, that's a square because the length and the width are the exact same measures. The question is, what number do I have to add here to make it a perfect square? Now notice, class, everything in here, you know what? I'm going to change the color of this just so you see that all these numbers in dark blue, they all came from my original equation. Oops. I haven't added or changed anything yet. Okay, now let's take a look at our diagram. To get a perfect square from these two terms, I'm going to have to actually find the value in this lower right corner. 4 times 4 is 16. So class, you're going to add 16 to make a perfect square here. That means you need to subtract 16 on the outside. And let's write our final equation. The actual perfect square of x squared plus 8x plus 16 is right here. It is x plus 4 squared. And then we had this leftover 4, but we added 16, so we have to subtract 16. This is 4 minus 16, which is negative 12. Now I'm going to go ahead and write this final answer. A of x equals x plus 4 squared minus 12. Class, both of these equations, believe it or not, the one we started with and the one we have now, these are exactly equivalent. If you graphed them, they'll graph as the exact same parabola. But I just want you to see, we actually turned this one into a perfect square, and we dealt with the leftovers over here. Let's do one more, question number 22. All right, same thing. Let's go ahead and group these two together. We're only going to look at these two. We're going to kick the plus 6 down the road. So here we go. We've got x squared. I'll do this in dark blue again. Actually, let me get rid of that plus 6. Let's do this in dark blue again to be consistent. So I've got here plus 6 is my leftover. Sorry, let's put that green parenthesis back where it belongs. Inside of our diagram, we've got x squared. 10x, negative 10x divided by 2 is negative 5x. and negative 5x. Class, again, notice I haven't changed anything. These four numbers are this exact same equation. There's my x squared, negative 5x plus negative 5x is negative 10x, and there's our 6. All right, so let's go ahead and complete our square. Not a problem at all. X times x gets me to x squared. X times negative 5 gets me to 5x. X times negative 5 gets me to 5x. That verifies this is a perfect square. So I already got my perfect square. X minus 5 squared. But now my issue is this. I had this plus 6 before, and now I have to actually subtract something. And the reason why is because to make this x minus 5 times x minus 5 perfect square, we have to figure out what this number is. Negative 5 times negative 5 is 25. That means we're adding 25 to make a perfect square. That means we have to subtract 25 to balance our equation. Otherwise, our equation is changing. So we added 25 to make our perfect square, x minus 5 times x minus 5. We subtract 25 on the outside, and here comes our final equation. A of x equals x minus 5 squared. 6 minus 25 is 19, negative 19. And I'm doing this in my head class. You can use a calculator for that to verify that. Don't think you have to actually do it in your head as well, unless you're able to. There is our final equation. This has a perfect square, the closest perfect square we can get, and then we're dealing with the leftovers. The 6 was already here, and we added 25 to make a perfect square, so we have to subtract 25 to put our equation back in balance.